Real estate investment practice problem using Onenote. Adjustable rate mortgage or ARM with a rate cap. Get ready because it's time to raise the stakes with real estate. Here we are in Onenote. If you have access to Onenote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side, Practice Problems tab, down in the 5120 Adjustable Rate Mortgage ARM Rate Cap tab. Also note, when using Onenote, take a look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're looking at our adjustable rate mortgage again, but this time, slight change from the prior practice problem in that we have a rate cap, as we did in the prior practice problem for an ARM adjustable rate mortgage. We always want to be comparing and contrasting it to the standard, that being a fixed rate 30 years. So here's an example of the fixed rate 30 year. We got the $100,000 loan, 30 years, 30 times 12 is 360 months. And we have the 10% that we're using as the rate. We would then construct our amortization table from the payment amount, this payment amount being calculated from the payment formula or function. We then have a nice even payment of that 878, about the interest then calculated all the way down based on the 10% on a monthly basis though. And then we can see how the payment will stay the same. We can see the interest and the principal changing as the time goes on, and the whole thing should be fully amortized by the end of the 30-year time period, getting down to zero, giving us that nice check figure at the end. Comparing and contrasting that now to the adjustable or ARM with the cap on it, we're going to start with the same $100,000 loan, 30-year, 360-month, initial rate this time being 11%, we're going to say. We have the annual rate cap, this is the new thing, of 2%. We have the lifetime cap of 5%, the margin of 2%. What does that all mean? Well, that's going to basically mean that we're going to have an index. The index could look something like this. Remember that we don't know what's going to happen in the future with regards to the index. That's why basically the risk related to the rate is now being transferred from the lender to the borrower. They can gauge it by the index, which is basically an indication of what's happening in the market as time passes. And whatever happens with regards to that index, we can tie then the rate change to it. This then being at a 2%. That means that whatever happens with the index, we're going to generally increase it by 2% as we did in the prior practice problem. But we have a little bit more safeguard this time for the borrower, not taking on all the risk, because now we have a cap designed to help a little bit hedge off some of the risk that is going to be taken by the borrower. That cap having an annual cap in our practice problem of 2%. So that means if this increase that goes from the index resulting in our rate increases more than 2%, we're going to cap it off at the 2%. And then we have the lifetime cap at the 5%, meaning that if I start with my original rate at the 11%, increase it by the lifetime cap of 5%, we get to 16%. We're saying this thing can't go over 16%. So you can see what this would basically do. It gives a little bit more assurity to the borrower and a little less risk than an ARM that did not have these caps in on it. You can think about what would happen in terms of the negotiation, because once again, now we've kind of hedged back the other way so that the lender's getting a little bit more of the risk and they might increase the rates a little bit or something like that. So that's kind of the play back and forth between the risk and the potential benefits of it. Now, if we think about the general concept with regards to constructing our table based on this information, remember the index is something that we don't know about when we take out the loan. So we can we can guess what's going to happen in the future. We're going to assume here that there's going to be a rate readjustment on a year-by-year basis. Or we can think about the index after a time period has passed, after 5 years or so, and then see what has actually happened with regards to the index and then with our rate. Obviously, when we're taking out the loan, we want to make some predictions of what we're going to happen in the future, and then get a worst case scenario, best case scenario, average scenario, try to figure out what the best strategy for us would be to do. But in any case, the index is out of our control, something that we would guess on. Then we can think about what would happen if there were no caps with regards to the rate, meaning the first year then typically isn't tied to an index because it is usually like a teaser rate, might be lower than usual, might not be tied to the index in the same fashion. After that, then it would be increased by the margin of 2%. So if the index showed 10%, we bring it up to 12%. Index shows 13%, we bring it up to 15%. Index showed 15%, we bring it up to 17%. And if it showed the index that is 10%, we bring it up to 12% here. Remember that this index could go up, could go down, be favorable, unfavorable, just depends on the circumstances in the economy. Then we have our restricted items. So once we consider what's going to happen with the index, we can then apply our cap rules to it and see what the rate will be after we apply the cap rules. So it doesn't really apply to the 11% because that's the first year. The second one, we can think about, okay, we can only go up by 2% according to the cap. So for year 2, if it went up, if it was 11 before, it can go up to 11, 12, 13% and not violate the 2% cap. It only went up to 12%. It's not violating the lifetime cap of 16%, 11 plus 5. So we should be okay there as well for the second one. Third one, the index went up to 15 and we were at 12 before. And if I pull my fingers out here, 12, 15, 12, that's 3. And there's a cap of 2. So we can't do that. Therefore, we're not going to go up to the 15, but rather only be increased by 2 due to the cap. We're not at the lifetime cap, which once again is 11 plus 5 or 16. So we're still under that one. Now then we're at 14% and the index went up to 17%. So now we can't go from 14 to 17. That's over 2 again. So that doesn't work. So we're just going to go up by 2 because that's the annual cap to 16%. So we're capped up at the annual cap. 16 also happens to be the upper limit of the lifetime cap, 11 plus 5. So we're at the lifetime cap. Then it goes back down, the index does, to 12. And that's okay. That's not going to violate any of our caps. We can go back down even more than 2%. So that's okay. So we're at the 12%. So these are going to be the rates that we actually will then be using to construct our information and our table. Then we can calculate our payments in a similar fashion as we saw with the prior presentations. We can calculate our balances in the 2 ways that we thought about in the prior presentation, which would be either with a formula or by constructing the amortization table as we go. Then we'll talk about the cash flow and the calculation of the IRR, the internal rate of return as well. If you were to graph out Note, then our rates down here, just to get an idea, the index being what would happen in terms of the index, the baseline, and the index could do basically anything. It could go down, it could go up. We don't know because, again, we're predicting into the future. And then we could see what would happen if there was no cap. That would be the orange line here, and it would be just spaced out 2%. And then we have this restricted item. This is the rate we're actually going to use, which you can see is a little bit nicer to us, the borrower, because it restricts a little bit what could happen on those extreme or more extreme kind of swings. So the caps could be, of course, a good thing to the borrower with regards to these types of loans. And although they do add a significant level of complexity, so you'd want to understand those to some degree as you're negotiating this kind of thing. Let's do some calculations then. We'll say we could do the payment calculation. So we've got our table, once again, index. This is the rate. This would be the rate that we're actually going to use after applying the caps. Then we can calculate our payment calculation, which would look something like this. I'm going to say negative payment, the rate. The rate is going to be that 11% that we're going to be using divided by 12 to get to the rate for a month. Then we're going to say comma, number of periods, which we'll think about in years first, and then multiply times 12 to get to the months. We start with the L5. L5 is going to be the 30 right here, which is in our data set. Therefore, it needs to be absolute. So when we copy it down, it doesn't move down. $sign before the L and the 5 minus the N1 represents this cell over here, number 1. That one we do want to copy down. Then plus 1, which is a hard-coded number. Why would we say minus 1 plus 1? Because that still comes out to 30. because when we copy this down, it will then be 30 minus 2 plus 1, or 29. Therefore, although complicated, we could just say 30. It wouldn't copy down that way. And this way, it will copy down. That's the purpose of it. Then we can put the multiply times 12 to get the months to get to the months instead of the years. Then comma, we got the present value. That's going to be the prior loan balance, which we can't see in the table right there, but it would be the prior loan balance, which was the 100,000, the starting point in this case. Once we have that, then we can calculate the balance at the end. We can do this by either looking at the amortization table or with a formula such as this, or we can do the formula and then double check it as we construct the amortization table. This is one way you can take a look at the formula. Ending balance then is going to be equal to R3. That's going to be this payment amount divided by the negative payment brackets. The rate is going to be the 11% divided by 12, comma. Then we're looking at the number of periods, which is 30. Right there, absolute reference because it's not in our table, minus N3, which is 1, getting us down to 29 years, multiplied times 12 to get us to months instead of years. And then the comma, the present value is just going to be 1. And that will then give us the ending balance of the 99,550. We can double check that by looking at our amortization table. There's the 99,550. As we construct our amortization table, these adjustable rates are kind of neat in that they'll always still kind of fully amortize out at the end of the day if we did it right. So we get like a double check figure by doing that. So in other words, this 952.32 is that 952.32 that we started off with. And we're just going to be multiplying then times the rate of the 11% here to calculate out. And if we take that all the way down, we basically just have a normal amortization schedule. We should get down to 0 at the bottom of it. And that gives us kind of that double check that we have done things properly, fully amortized, as does also the ending balance matching out, meaning this 99,550 matching out to this ending balance here. Now, if we did it again, let's do it again. Now, notice that you can then copy down these formulas. That's why we put these absolute references in there. But it's staggered, so the next cell will not appear until the balance comes into place. So once you get like one calculation down, you can copy both of them down, and they should work if you do them properly. We do work this problem in Excel if you want to test that out for yourself. Also note, hadn't mentioned, when we applied our logic test to these cells for the restricted amounts here, we kind of thought about what would apply. What should apply? Should it be restricted by the 2%, or should we take the same number that is on the left, or is there restriction by the lifetime limit? So we mentally thought about that and populated each one. You can do those with logic formulas, and we do that in Excel as well using if formulas, which says if then this, then that kind of logic. They get a little bit complex, so I don't want to do them here in a OneNote presentation. But we do those in Excel, and it's quite useful for something like this because as you project out to different scenarios into the future, such as different index calculations, it would be nice if you had a table that you didn't have to go through and rethink with your mind to figure it out, and just had an if logic function format to run multiple scenarios and give you some idea of what's going to happen. So anyways, we're going to go back to here. Here we got the next payment item. This is going to be the payment item here for the second one. So we're calculating this one at the 12% would be negative payment rate. The rate's going to be the 12% divided by 12, and then comma. We're looking at years first. L5 is representing the 30 years minus N4, which is now moved down to be 2. That's going to represent this 2 cell plus 1. That's 30 minus 2 plus 1, or 29 at this point. Years multiplied times 12 gives us the months, comma, the present value then being the prior balance, which I believe was at 99. We don't see it in this column, but it would be that amount there. And that would give us then that 102771. That would help us then populate the second ending balance if we copied the formula down for the ending balance, which once we had that, if we copy down the payment, would populate the next payment, right? That's how these staggered kind of cells would work. So this calculation for the ending balance, which we can also see on the table, if we looked at the amortization table or double check on the table, which we will do shortly, which would be equal R4, the cell to the left, divided by negative payment, PMT, brackets, rate. The rate would then be the 12% divided by 12 to get the monthly rate, comma, number of periods is going to be first in years. That L5 representing the 30, bracketed so we can, or absolute so we can copy it down. That's what the dollar signs are for. Minus N4, which is the 2 over here, gives us 30 minus 2 or 28 years times 12 to get us in months. And then the last one is comma 1 for the present value. That gives us the 99,141. We could double check it to the table at the end of year 2, 99,141. We would then need to change our table based on this new information, the new payment being $1,027.71. So about $1,028, it's rounded without the pennies, and the rate would be the 12%, meaning we would now be calculating our rate based on the last balance, 99550 times 0.12 divided by 12 would give us about the 999 or 995. Then we would copy all that, and we're going to copy that all the way down, assuming that we're in year 2, and we don't know what happened in year 3, right? And so you can kind of see the amortization table as if we did the whole thing as if it's going to stay in year 2's numbers, and it will still be in balance. So we can get this whole thing kind of populated down to 30, and it should fully amortize down to 0, giving us that nice double check that things are going the way things are supposed to be going. And so that's good. They're going the way they're supposed to go. So then the next one, we can see the next one on year 3. We got the 1,180.63. The rate went up to 14%. It was capped because the index went to 15. It was capped for the 2% rate restriction. Calculating the payment, negative payment. Q5 is the rate divided by 12. 14 divided by 12, comma, number of periods is going to be that 30 years first, minus N5, which now represents that 3, plus 1, so basically 30 minus the 2 times 12, and then comma, the present value is going to be the prior balance, which would be the prior balance here. And so that'll give you the 118.61. And then we could calculate the ending balance, either using the table, either using the amortization table or a calculation. Calculation looking like this, R5, which would be the payment divided by the payment calculation rate, then being the 14% divided by 12, comma, number of periods, which would be L5 in years, 30, minus N5, which would represent that 3, closing the brackets, that's the years times 12 to get the months, comma, and then you got the present value, which is 1, giving you the 98,835, which would then populate if you copied the payment formula down the next payment. Let's check to see if that 98,835 is at the end of year 3. 98,835 right there, 98,835. Our table then, if we were to update it as we go for year 3, would have payments of 1,180. So the payments down here for year 3, 1,180, and I think it was 12% was the rate, I believe. Is that what we're on year 3? Let's check it one more time. No, we're on 14%. So year 3, the last balance was 99141 times 0.14 divided by 12. That would be the 1,157. And if we copy that all the way down as if, we don't know what exactly is happening in year 4 now, we just copy this all the way down, we should still be fully amortized, giving us kind of that double check on the table, which is pretty neat. There's the 0, check in, double. 2 checks have been applied to this thing, which gives me a little bit more confidence than if there was only one. Okay, so then the next one is 16%. It went from 14, index went up to 17, but got capped at the 16. Negative payment, the rate then is going to be the 16 divided by 12, comma, number of periods is going to be the 30, represented by L5, absolute reference, minus N6, which is representing this 4 over here, plus 1, brackets, times 12 to go from years to months, and then comma, present value would be the prior balance that we were on in the prior period. That giving us the 1336.08. We can then calculate the ending balance with a formula and or with the tables, which would be R6 representing the payment amount divided by the payment PMT brackets, the rate being the 16% divided by 12, comma, then the years, L5, absolute reference representing the 30 years, minus N6 representing the 4 brackets times 12 to get to the months, then comma, present value 1, giving us the 98598. Let's see if after year 4 we're at 98598. After year 4, 98598. There it is. Looks good. We can then update the table with a payment of 1336 and 16 at the percent year 4. So there's the 1336. Payments have been adjusted. 16%. It's just absurd. What is going on in the world today? Something's happening in the world today, and I don't understand what it is. So there's going to be the 1318. And if we copy that all the way down, as if that's going to apply all the way down, we should be fully amortized once again. Once again, we have indeed fully amortized. Let's do it again. So now we're on the payment. Next payment. This is going to be the year 5, I believe it should be. So payment, the Q6, it should be representing the 12% divided by 4, 30 minus N7, which is going to be the 5 plus 1 brackets times 12, and then comma, present value. That's going to be the prior balance. And then we can calculate the balance down here, which would be the calculation of the payment divided by the payment calculation rate, which would be the 12% divided by 12, comma, the years, which would be 30, present, totally absolute reference, minus N7, which would be the 5 times 12 to give us the months, comma, 1 for the present value. That gives us the balance of the 9811. That should be what we get after year 5. Let's check it out. 9811 right there. That looks good. Then we're going to change our payments again to 1032 and 12% for year 5. 1032 has been adjusted. 12% means the last balance we were at, 98598 times 0.12 divided by 12 would give us that 986. So it looks like it's going properly. If we copy that all the way down, then once again, we should be fully amortized again. So really good problem to work in Excel. Highly recommend it. Once we have this information, we can then kind of get our table that we populated even without the amortization table and figure out a nice quick IRR, the rate at which our cash flows would be 0. We can do that by then taking our cash flow, starting with the 100,000, representing basically an inflow. That's what we got, even though we didn't actually get it because that's what we used to pay for the home. But we can imagine we got it, then paid for the home. And then we got the outflows, which we can imagine the payment of 952.32 times 12, the 11,428. And then we could do the same so on for the 5 years and get our cash flow, taking the IRR then representing the rate at which that cash flow would be 0 on a yearly basis, kind of giving us an average, in essence, of the rates. Although an average would not be as accurate as the internal rate of return, especially if we had some more complexity in terms of, how often the rates are going to be changing if they weren't even and so on. So that's going to be our internal rate of return. Also note that that internal rate of return is going to be calculated based on the idea that these flows are happening at the end of the year, because that's the assumption made with the internal rate of return, even though we see that these flows are actually happening in 12 payments, 12 months during the period. It would be therefore more accurate to do this on a monthly basis, which we'll take a look at in a second. But it's a nice, good little estimate we have there. Then we could populate an pivot table, which we'll do in Excel as well. Just going on to our amortization table, adding the pivot table. I won't go into a lot of detail with it, but you can do that fairly quickly and get your year-by-year breakout. Notice the table we constructed has a lot of this information on it, but it doesn't have really the interest on it. which might be something you could derive from the table we would put together, but it would be nice to have the interest calculations there as well. And of course, we're calculating it out all the way down for the 30 periods that we've constructed using our amortization table. And then the interest and the other calculations are something that you can use and pull from to make kind of year by year calculations, especially if you're taking into consideration taxes and things of that nature. Then we could think about the same IRR calculations. Remember, if you're comparing and contrasting these more complex types of loans, you might be running a best case scenario, a worst case scenario, a comparison of an ARM that has caps versus one which doesn't have caps and possibly has different rates, a scenario where you're holding on to the property for 5 years versus 30 years versus 10 years or 15 years. So you might run different kind of IRR calculations to see what your return would be, taking into consideration time value of money under different scenarios, trying to guess what your risk would be and so on. So here's just an example of that. If we took basically the cash flow for the whole 30 years based on what we have here, even though we stopped the index at 5 and just kept the same amount going, we'd have an inflow of the 100,000. The outflows then are populated here. And then if we took this all the way down to 360 payments, all the way down, we got a total flow of 276.31. The IRR, the rate at which this series of payments, now being a little bit more accurate because we're on a monthly basis, then, and this is a yearly IRR, but a monthly that would give us the 12.42 internal rate of return, which we might be able to compare with other potential investment type of opportunities, taking into consideration risk and so on as we do those kinds of comparisons. Then we have the next one, which we might want to do like for 3 years. So we might say, what if I'm planning on getting out in 3 years? That means that we'd stop at 36. If we did so, we'd have to pay off the ending balance at that point. So if I look at my table for 36 periods, which is 3 times 12, we would then get down here. So we'd have to pay off that 98 right there. So 3 years stops right there. We'd still have 98835 plus the 1181 last payment. That's where we're going to get this 115 or so that we still have to pay off, totaling the cash flow net of the 100 we got up top, the 36,762. IRR then at that time is 12.21, the rate at which that series of payments would be 0. And then we could do it one more time for the 5 years. So if we did the 5 year, the 100,000, and then we took 5 times 12 gives us 60. And then that last payment, once again, is after 60. So if I look at my amortization table for 60 periods, we'd have to pay off the loan balance right there at the 98011 plus the last payment 1032. That's the 9943. That's our last item right there. Total cash flow 64,359. The internal rate of return, the rate at which that flow would be 12.83%. That then we can compare to what we got up top, which was our estimate, 12.81. So these same time frame, although this one was compiled into years and the other one in months, the months being slightly more accurate, but you could see how this would be a good round, good estimate to go on, a little bit easier to work with. On the yearly basis calculations, you could do the same thing, pulling the yearly information, possibly from the pivot table up top, and that would give us the same stuff that we got when we did in essence, this item right there at the 12.81, the 12.81. So we got a lot of different tools that you can that can be used once we put this kind of thing together. Obviously, there's a lot more risk going on when you're looking at the adjustable rates. You as the borrower taking on more risk, so you'd want to see best case, worst case, comparing to other options and so on and so on. And these tools can help with that.